Hey guys, today we're going to look at solving linear systems by graphing. First of all, what is a linear system, or what is a system of equations? Well, a system of equations is an example where we're going to have two, or it could be more, but most likely two equations where we are trying to find the ordered pair that they have in common, or the ordered pair that satisfies both equations. So when we graph these today, what we're going to do is we'll graph one of our equations, we're going to graph our other equation, and then what we want to find is the point that they have in common. And whatever point that this is that they have in common, this is what we refer to as the solution. So our goal today is to graph and to figure out where our two lines or equations cross. So before we do that, one way that we always want to make sure that we check a solution is that wherever this intersection point is, wherever this solution is that we find, it has to work for both equations. Meaning, if we plug it into each equation, it has to be true. If we plug it into an equation and it is not true, then that ordered pair cannot be a solution of our system. So first of all, and this is going to be the first part you see in your assignment today, is checking to see, is this point a solution of our system? So if I plug 2 in for x and 2 in for y in each of these, what's going to happen? Well, let's start with the first one. 2 in for x and 2 in for y. All right. If I simplify, I'd get 2 plus 4, 6. And then does 6 equal 6? Yes, it does. So we know that the ordered pair 2, 2 works for my first equation. Now we need to check our second one. So 3 times 2 minus 2 times 2. Does this equal 2? Well, we'd get 6 minus 4. 6 minus 4 is 2. That's true. So now, since this same ordered pair worked for my first and my second equation, then that means it is a solution of my system. So, why don't you go ahead and try plugging these in and see if this ordered pair is a solution of this system. So go ahead and pause your video and give it a shot. All right. So when we plug it in, it does work for the first equation, but it does not work for the second equation. So since it doesn't work for both, we would say that this ordered pair would be not a solution. All right. So now on to our big idea for today is, again, this whole idea of graphing. So now instead of having the point given to us where they cross, we need to graph them to try and find that point. So these are going to be the steps that you're going to want to do today in your assignment. So first of all, let's write each equation in a form that's easy to graph. So for the most part, this is usually y equals mx plus b. Now we don't have to use that, but I do think that's the easiest way to graph. Then we want to graph our equations in the same plane, meaning we're going to graph them both on our same coordinate grid. Okay? And then we want to figure out where do our lines cross. And then once we estimate or figure that out, some are going to be easier than others, but once we figure that out, it's always a good idea to plug it back into our equations to make sure that it works. So let's do an example. All right. So this one right here, we are graphing y equals 3x minus 2 and y equals negative x plus 2. All right. So both of them are easy to graph right now, so they're both in our slope-intercept form. So let's go ahead and let's graph this one first. So if I graph this, y equals mx plus b, I know negative 2 is my y-intercept, and I'd have a slope of 3. So that means up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Okay, or I could say down 1, 2, 3 over 1. So I know that the line for this equation looks like so. Now I'm going to try my other one. Y equals negative x plus 2. This would have a y-intercept of positive 2, and then a slope of negative 1. So down 1 over 1, down 1 over 1. And you can already see that my lines are crossing in. It looks like it's at the point 1, 1. Okay? So it's always a good idea to go back and plug those in. So if I plug in 1, 1 to my first one, I would get 1 equals 3 times 1 minus 2. Well, this would be 3 minus 2, which is 1, so that one works. My other one, if I plug in 1, 1, 1 equals negative 1 plus 2. 1 equals 1. Sure enough, that's our solution. All right. Last example for today, we want to go ahead and graph these. So I think the easiest way to do this is to get them into an easy way to graph. So we could solve for slope-intercept, or these are actually what we called standard form, and we talked about quite a while ago. But we could graph these using a simple XY chart. So let's do this. For the first one, I'm going to go ahead and graph this as is. So I'm not going to simplify this, and we could graph this using our plugging in points method. Or what we did in standard form was we said, hey, I could plug in 0 for x to get a point, and I could also plug in 0 for y. That's going to make this easy. So if I were to plug 0 into x for this one, this would disappear. So negative 2 times what is negative 8? It would be 4. And then let's try plugging in 0 for y. So if I plug in 0 here, okay, this would disappear. So 2 times what is negative 8? Negative 4. All right, so I have a couple points that I could graph. I'm graphing 0, 4. I'm also graphing negative 4, 0. So I have 2 points. I can draw a line here. Now we could do the same method with our other line, but I'm going to go ahead and just solve this one in the slope-intercept form, because I think that's my favorite way to graph anyway. So to solve for x, subtract 2x from both sides. And then the last thing would be divide everything by 2. So I'd get y equals negative x plus 2. So I have a y-intercept of 2, a slope of negative 1, so down 1, right 1, or I could say up 1, left 1. And I can see where they cross, which would be the point negative 1, 3.